Am I audible?
Yes, sir.
So in the last class, we have discussed about the set transform, some problems, the set transform. Combined some important results already got that just by write combinedly all the formula. What is x of n? What is set transform of this? That is set of x of n. In case x of n is 1, then set by set minus 1. Mod is set greater than. Second one is a power n z by z minus a. Mod is set greater than a. A power n minus 1 1 by z minus a. Fourth one n z by z minus 1 whole square. So you have to remember these results. N square z square plus z square plus z by z minus 1 whole cube. N cube z into z square plus 4z plus 1 divided by z minus 1 whole power 4. Next one, seventh result, n power k for n power k minus z minus z d by d z of z transform of n power k minus z d by d z in z of n power k minus 1. Soften z of x of n. Some more results. 8 n into n minus 1 2 z by z minus 1 whole cube. N into n minus 1 n minus 2, 6z by z minus 1 whole power 4. 1 by n 1 by n log z by z minus 1, where mod is at greater than 1, n is greater than 0. 1 by n plus 1, 1 by n plus 1 is at log z by z minus 1. 1 by n minus 1, 1 by z log where n is greater than 1. 1 by n factorial e power 1 by z over 1 by z. 1 by n plus 1 factorial z e power 1 by z minus z k into z by z minus 1 minus 1 whole power n z by z plus 1. 1 by a whole power n is a z by a z minus 1. E power a n z by z minus e power a. E power minus a n z by z minus e power minus a. 20 cos n theta, the last class we have discussed, cos n theta z into z minus cos theta divided by z square minus 2z cos theta plus 1, where mod z greater than 1. Of n, set of x of n. 21 sin n theta, sin n theta z times sin theta divided by z square minus 2z cos theta plus 1. Mod z greater than 1. 22 r power n cos n theta. R power n cos n theta is z into z minus r cos theta divided by z square minus 2zr cos theta plus 1, sorry, plus r square mod z 23 r power n sin n theta. 2 zr sin theta by z square 2 zr cos theta plus r square. Cos an equal to z into z minus cos a divided by z square minus 2z cos theta, not theta, cos a c plus 1. Similarly, you can write the two more results. A power n cos n theta, a power n sin n theta. You can write a power n cos n theta, a power n sin n theta. That is set into, or this set into z minus a cos theta divided by z square minus 2z a cos theta plus a square. Similarly, a power n sin n theta is z a sin theta divided by z square minus 2z a cos theta plus a square. The last class I have given one problem. Find set transform of sin n pi by 2 plus a. Sin n pi by 2 plus a. Okay. How to find this? First of all, we have to write sin n pi by 2 plus a equal to sin n pi by 2 cos a plus cos n pi by 2 into sine A. Okay. You taking the Z transform for this. Take the Z transform of this, then you will get that cos A is the transform of sin n pi by 2 plus sin A is the transform of cos n pi by 2. So for this, how can you calculate this? Z of sin n theta, Z of cos n theta, you have to apply here. So here theta equal to pi by 2. This is the format of sin n theta, cos n theta format. Then substitute theta equal to pi by 2 in Z transform of cos n theta and Z transform of sin n theta. Then what you get? Cos A. First we will find that sin n pi by 2. Z of sin n pi by 2 is, so first cos A into Z of sin n pi by 2 is substituting theta equal to pi by 2 in sin n pi by 2. That is Z sin pi by 2, Z sin pi by 2 divided by Z square minus 2Z cos pi by 2 plus 1. So you will get that Z by Z square plus 1 plus sin A into what is cos n pi by 2? Z into Z minus cos pi by 2 divided by Z square minus 2Z cos pi by 2 plus 1. But cos pi by 2 value is 0. So this term is 0. Here also this term is 0. This term is 0. So remaining you have to write, that is equal to cos A is Z by Z square plus 1 plus sin A is Z square by Z square plus 1. So answer for this. Similarly, you can practice some other problems. Z transform of sin square n pi by 2. Similarly, you can try that Z transform of sin cube n pi by 2. So this problem is based on this trigonometric formula. Sin square theta and sin cube theta formula we can use, and then we can find the answer for this. That is, anyway, if you remember that sin n theta cos n theta formula, Z transform of sin n theta cos n theta, easily you can do that. Similarly, one more problem also you can do that. This first problem, second problem, third problem, Z transform of cos n pi by 2 plus pi by 4.
Excuse me, sir.
Yes.
Sir, can you write the question number 1 and 2 little bit down? It's not visible.
No, it's down only. Okay.
Yes, sir. Now it's visible. No, sir. It was not visible. Now it's visible.
Next one, differentiation in the Z domain. Differentiation in the Z domain. What is differentiation in the Z domain? Z of n into f of n equal to minus Z d by dz of f of z. So let f of z, we know that f of z equal to z of f of n. That is f of z equal to summation of n equal to 0 to infinity f of n z power minus n. So if you are differentiate on both sides, d by d z of f of z equal to d by d z of summation of z power minus n. So z power minus n is minus n z. If you are differentiate with respect to z, what you get? The next step minus n. So that is equal to summation of n equal to 0 to infinity. F of n is there minus n f of n. So minus n minus 1. So this can be written as minus n into f of n minus summation of n equal to 0 to infinity n into f of n z whole power minus n by z, we can write whole power minus n by z. So this side cross multiply that z here, z into d by d z of f of z equal to, and minus take it here, that is equal to summation of n equal to 0 to infinity n into f of n z power minus n. Therefore this is a z transform of, therefore this is a z transform of n into f of n, that is equal to minus z into d by dz of f of z. Fine. Z of n square. Fine. Z of n square. So we know that Z of n into f of n equal to minus this one, z into d by dz of f of z. So therefore here we can take that n square can be written as this n square can be written as n into n. So that is equal to minus z d by dz of f of n. That means z transform of n. What is z transform of n? Z transform of n is d by dz of z by z minus 1 also. So this can be written as minus z into minus z into d by dz of z by z minus 1 also. Okay, if you are differentiate with respect to z, what you get? Minus z minus 1 minus z by z minus 1 whole cube. I skipped two steps. Okay, so finally we'll get that z square plus z of z square plus z minus 1 whole cube. Z minus 1 whole cube. So continuously like that z of n power k equal to minus z d by dz of z of n power k minus 1. It is 140. Okay.
Excuse me, sir. Sir, your mic is in mute.
Z of a power n f of n equal to f of z by e. Of z by e. Also prove that z of a power minus n of n equal to f of a is it. Of a is it. So how to prove this? Write the proof. Given f of z equal to z of function of n. So that is equal to summation of n equal to 0 to infinity f of n z power minus over minus n. So what is z transform of a power n f of n? That is equal to summation of n equal to 0 to a power n f of n z power minus n. Very simple. Combine that summation of equal to 0 to infinity. Combine this. How to combine? This can be written as a power n. So 1 by a power minus n f of n z power minus n. So this can be written as summation of n equal to 0 to infinity f of n z by e whole power minus n. So it is the z transform of not z. Okay, it can be written as f of z by e. F of z by e. Similarly, we can prove the second one. Similarly, we have to prove that the second one. In the same steps, we have to follow. Prove the second one. Fine. Fine. Z transform of a power n into n. So what is z of a power n f of z? That is equal to f of z, where z tends to zk. Sorry, z tends to z by a. Please mute your audio, Delhi. Register number 10. Register number 10. என்ன ஆன் பண்ணி
Yes,
வச்சிருக்கீங்க?
sir.
10
No, sir.
No, no. Please mute your audio. Delhi. Okay, fine. So here, how to use this first shifting theorem in the problem. So here, z of this can be written as z of a power n equal to Jashmita. Mute. Please mute your audio. A power n. So what happened? We have to find the z transform of n, substituting z equals to z by j. So what is z transform of n? Z by z minus 1 whole square. Z by z minus 1 whole square. So where z tends to z by a, that is equal to z by a by z by a minus 1 whole square. So what do you get finally? Z by a. So z a z by z minus a whole square. Similarly, we can do that z transform of a power n by n factorial. Some problem for practicing the same method. Find z transform of a power n by n factorial. A power n by n. When it is multiple with a power n, you have to use the shifting theorem. A power n cos n theta, a power n sin n theta is the transform of a power n cos n theta is the transform of a power n sin n theta is also good. So for example, I can do only one problem. Z of a power n cos n theta. Z of a power n cos n theta. So this can be written as z transform of cos n theta, where z tends to z by a. So what is z transform of cos n theta? Z into z minus cos theta divided by z square minus 2z cos theta plus 1. Z into z minus cos theta by z square minus 2z cos theta plus 1, where z tends to z by a. If you are substituting z tends to z by a, finally what you get? Z into z minus a cos theta a cos theta divided by z square minus 2az cos theta This is like r power n cos theta only, but here we are using the shifting theorem. Previously we are not using the shifting theorem to solve this. Find 2 power n and square. Find 2 power n and square. So we know that the Z transform of a power n f of n equal to Z transform of f of n where n tends to sorry Z tends to Z by k. Okay. So here instead of a power n, 2 power n is there where a equal to 2. Therefore, Z transform of 2 power n and square, that is Z transform of n square where Z tends to Z by 2. But Z of n square value is Z square plus Z by Z minus 1 whole cube. Z tends to Z by 2. So if you are substituting Z tends to Z by 2, you will get that 2Z into Z plus 2. After simplifying, I am doing. So here Z tends to Z plus 2 means Z by 2 whole square minus Z by 2 divided by, what is this value? This value is 2Z into Z plus 2. 2Z into Z plus 2. Z minus 2 whole cube. Second shifting theorem. Second shifting theorem. Z of f of n plus 1 equal to Z into f of z minus f of 0. So here, how to write the proof or solution? What is Z of f of z? Z of f of z equal to summation of n equal to 0 to infinity. Not f of z, f of n. F of n z power minus n. But Z of f of n plus 1 that we required. That is equal to summation of n equal to infinity f of n plus 1 that power minus n. Wherever that f of n plus 1 is there, you have to write f of n plus 1. So many of them have done the mistake. They are taking that here also they are substituting n equal to n plus 1. That this is not correct. We are changing only that f of n plus 1, f of n to n plus 1. That's all. No need to change here. One more thing here, if you are multiple with z, what happen? Z summation of n equal to 0 to infinity f of n plus 1. And then when we multiply with z, you have to divide with z. Z power minus n to z. So z summation of n equal to 0 to infinity f of n plus 1 z whole power n plus 1. Z whole power n plus 1. So what is the next step here? Here n equal to 0 means if we take that n plus 1 equal to some m, take n plus 1 equal to m, then n equal to m minus 1, n equal to m minus 1. If n equal to 0, if n equal to 0, m equal to 1, equal to 1. So these are the things we are taking that. So what is z of f of n plus 1, that is equal to summation of, it is start from n equal to 0 na. So if n equal to 0 means m equal to 1. So m equal to 1 to infinity, m equal to 1 to infinity, set here f of m, f of m set power minus m. But we need that summation of m equal to 1 to infinity, but I want that m equal to 0 to infinity, then only it is f of z. So if you are taking that m equal to 0 to infinity, f of m is at power minus m. So if I add that one term f of 0, that means here I add that plus f of 0 minus f of 0. Plus f of 0 minus f of 0 I am adding. So plus f of 0, if I combine with this, then what is remaining here? Minus f of 0 is remaining. So sorry, z into f of 0. Because here multiply with z now. Here z into f of 0. Z into f of 0. So here z into, it is that f of z minus z f of 0. What is the value of this? Z of f of n plus 1 is an important MCQ. Is that of then only shifting theorem? Z of f of n plus 2, z of f of n plus 2 equal to z square f of z minus f of 0 minus f of 1 z power minus z power minus 1. So here in generalize we can write that, in generalize we can write first one, z transform of f of n plus k, f of n plus k equal to z power n f of z, z power n f of z minus summation of I equal to 0 to k minus 1, k minus 1, f of I, f of I, z power k minus I, k minus I, n greater than equal to minus k. Second note, note 1, note 2, z of f of n minus 1, z of f of n minus 1 equal to z power minus 1 into f of z, f of z by z. Unit impulse stop recording.